So, kinetics, reaction rates. We're talking about converting reactants to products and the time that takes. So, no matter what our reactants are, whether it be an iron nail in water, whether it be the iron 3 nitrate and thiocyanate, whatever it is, we care about how the reactants combine, how they're converted into products per unit of time. And so that rate of conversion to products over time is what we call the rate of the reaction. Now, the book shows you this handy-dandy diagram. The main thing about this that you want to pick up on is how do we know how long it takes and how do we monitor the change, and that's basically we look at the changes in concentration. So we look at the changes of concentration of the reactants versus the products, and so as more and more products are produced, we have fewer and fewer reactants, and so we can see that change in concentration over time. Now, the book shows you this table in 14.1. A couple of things that you want to notice as you look at this table is that we have our equation. It's a single direction. Notice that the rate, the concentration, as we look here, look at the change in concentration over time. And this is primarily because as that concentration is changing, okay, it's because there's fewer collisions. So I have fewer and fewer reactants to produce the products. So we see that decrease in the concentration over time. And it's that change in concentration over time that gives us what we know as our reaction rate. So we can then also produce a graph related to this information. And the graph related to this information, you can see how the concentration of our reactant is changing over time and it's decreasing. And so we can calculate what's going on in terms of looking at a before and after concentration in order to look at how it's changing over time, and that gives us our rate law. Now, well, it leads us to our rate law. Okay, one of the things to pick up on as you look at this is notice that we have created two separate rates. We have the rate of loss of my reactant, and that's going to equal the rate of the formation of the product. So in essence, as the reactant disappears, we see the product forming. Now, there are different factors that are going to affect this because, as was mentioned earlier, we said that we affect the number of collisions. So how do we change the collisions and the types of collisions and what's going on? And that's where we look at the factors that affect the reaction rates. So we know that the physical properties, the physical states of the reactants are going to affect the reaction rates. And we talked about this a little bit when we mentioned if I had solid iron 3 chloride and silver nitrate versus the liquid form. So the physical state does matter and affects how the reaction can occur and the rate of that reaction. Additionally, the overall concentration is going to affect it. If I have a lot of stuff available for collisions and increasing those number of collisions, the more collisions I can produce, the more molecules that will collide, the greater the likelihood of a reaction. Temperature, so we saw from the PhET simulation, as you increase the overall temperature of the reaction area, then I have more collisions. I have more collisions with enough energy, and I can affect the reaction rate. And lastly, the presence of a catalyst can affect the reaction rate. Now, all of this, basically, what we're talking about is we're talking about affecting the rate of a reaction by determining the time. So each of those things that affects the reaction rate actually is impacting this because it determines how much of each of those reactants, how fast the reactants are used up and how fast the products are formed. So when we talk about speeding up a reaction rate, really what we're impacting is we're trying to affect the rate of time required to produce a reaction. Now, the only reason I went ahead and included this just because it's a nice reminder about as A decreases, as B decreases, we see the increase in C, we see the increase in D relative to that. And the nice thing about this is it's a quick reminder that your coefficients still matter. Even when we deal with kinetics and we're talking about rates, the coefficients matter. So for example, if I have 2 HI producing H2 plus I2, well, then this is my reaction rate, isn't it? So for every half of the HI, I get an I2. So that's all we're talking about. The main thing, again, going back, is the factors that affect our reaction rate are the factors that are going to affect this rate over time, this change in the concentration over time, and that those factors are in essence the physical property, the physical state of the reactants, the concentration of the reactants, the temperature of the state, and the presence of catalyst. And we'll actually spend a lot of time talking about catalysis later on.